Hi from rtcStats. I think that we have something unique for you this time, and that's the Uneeq service, which is a kind of a video avatar that works and behaves differently than others with WebRTC. Let's dive in to see what it is that they're doing.
Yes, so the first thing we noticed that we show it on rtcStats as connected to pixel streaming, which is Unreal Engine's WebRTC code base.
Yep.
And that is quite unique. We haven't seen that one used often.
Yes, I think the most interesting part though is this.
Yes, and we scratched our heads a bit because there is, you can talk to the avatar, it responds to your questions, but we see here there is no outgoing audio, no outgoing video, only incoming audio and video. And we dug in a bit, and it turns out that the outgoing audio is sent via WebSocket to the server, not even the signaling server that should be controlling the WebRTC instance, different server.
I think if you combine that with pixel streaming, it makes a bit of sense because pixel streaming comes from Unreal Engine, if I remember correctly, and they use WebRTC for that. So most likely Uneeq is using Unreal Engine to create and generate the avatar over the NVIDIA GPU. Now I'm just stretching, just waving my hands around that. And that means that it was easier for them to have a different path for the audio, and they simply chose something that isn't WebRTC because they didn't have their own WebRTC infrastructure. They used Unreal Engine for that. So it was just simpler for them to use something they knew, which was probably WebSocket.
Yes. So audio goes over WebSocket, there is probably transcribed, and then it's fed into Unreal and the character generation there in the backend.
Okay, let's see what we can see from the connections themselves.
Yes, so it's only a subscriber connection, incoming audio and video. Turn servers, they run their own. A bit high latency, I would say 700 milliseconds for the ICE connection, and then only 275 for DTLS, some kind of routing issues there.
Okay. Then for the streams, we've got only audio and video incoming again.
So let's look at the audio one and the bytes. So we see 512 kilobits per second, which is the highest quality Opus can get you. I think it's stereo. We'll see that later in the SDP. And you can see the usual behavior of taking turns when the model is speaking and encoding silence when it is not. If you look at the packets per second.
Sorry.
Yeah, 50 packets per second, so no discontinuous transmission, which is what I would think as well.
But this, I guess it's a bit too high. It's like useless bitrate that is being sent, probably.
Yes, this is an Opus bitrate that's more for music and almost like lossless. It's not built for voice, so it's going into the KELP mode in Opus and wouldn't use it for this use case. So 100 kilobits at most.
Okay. Let's see what happens with video.
Yes, if we look at the bytes, it's a relatively high bitrate. And what I noticed when we visited the homepage, it was like, okay, it's a small window. It already starts talking to you if you don't interact with it, greets you, which is done very nicely. But it is encoding 1080p video and then displaying it in like 320, 180.
Yeah, so that was...
And 6 megabits per second.
Probably if you were going to put this on a website, go for lower resolutions and increase only if someone expands the window or whatever.
Yes. I mean, that's the classic pixel counting you're talking about all the time.
Yes. Okay.
So very high bitrate, 6 megabits per second. Not high for 1080p, but too high for this use.
Also, it's synthetic, the actual videos. You might even be able to reduce the encoding bitrate a bit and still have the same kind of quality.
Yes. I mean, that's basically looking at things like QP and PSNR on the server, tuning it.
Okay.
Yes. And if we go for the logs.
Devices, it does get user media because it needs my audio, but sends it over the WebSocket. And let's look at the logs again.
Yes, so we see SDP munging in that local description, one change.
No, 2 changes here for the video.
Well, that's a fairly standard thing. I don't think it's necessary to do.
Okay.
Here. It is something that lets the pixel streaming stuff ramp up a bit faster.
Okay. And this one is
Stereo audio. And this tells the encoder on the pixel streaming side had to set the max average bitrate to 510, which is the maximum.
Yeah.
Wouldn't need to be done with SDP munging, but it's okay.
Okay. So that was quite unique. If you need to go analyze your own service with WebRTC, come check us out at rtcstats.com. Thank you.
Thank you.